So, good morning. Today's session, I will going to discuss about programming language of Cortex M3 process. Usually, in any microcontrollers, we can go for assembly level programming only. But in some applications, we can use C program also. Okay. Once comes to this Cortex M3, we can program either in the assembly level language or C level language. This is what generally we are using it. In addition to that, one more high level language like National Instruments LabVIEW we can use to implement. The LabVIEW software is available in our college, so we can implement by using this LabVIEW also. So before this, I'm going to explain brief about that languages. Usually the machine understandable only computer machine understandable only machine level language. The machine level language is nothing but so sorry. The machine level language is nothing but so only ones and zeros means that computer machine understandable only 1 and zeros. This is called as machine level language. 1 or 0, true or false, yes or no, high or low. Only two states. It belongs to the machine understandable language. So after introduce assembly level language. So in assembly level language is nothing but they can use mnemonics. Mnemonics is nothing but they can use move like this. Sorry, not written. In the machine level language, they write like this: move a comma b. This is what in the assembly level language. Then the finally high level language. In this high level language, I can use one is called as a machine level, sorry, middle level language or procedure oriented language, then object oriented language. The procedure oriented language is nothing but C. This is the language, the procedure oriented language, example C program. In C programming, we are going to write it in the form of printf, scanf, for statement, if else, while loop, the similar condition statement also using, and along with that, it is another way it is called as top down approach. C language is nothing but top down approach, or also called as a procedure oriented language. So another language it is called as a object oriented language. Oops. So example C++, Java, these are all belongs to that object oriented language. In object oriented language, we have everything we have written and executed in the form of object. The two main things to be considered in the object oriented programming, one it is called as a class. Second one it is object. Object is instance of the class. The class is nothing but template. The temporarily it will be created. That is what the class. And then can use number of object within that class. There in the class we can use different types of keywords also, public, private and all these things. But the code, what we call in C programming, subroutine, small subprograms, everything here it will be written in the form of object. It is a one object. So finally all the objects are declared in the temp class. Okay, this is what is called as object oriented language. In the example for object oriented language, C++ and Java belongs to object-oriented language. C belongs to the procedure-oriented language. And all microcontrollers assembly level language belongs to this assembly language. Then ones and zeros, binary numbers, belongs to the machine level language. These are the three main languages they classified for the structure of writing the programming. First one is machine level language, second one is assembly level language, third one it is high level language. Now, once comes to that Cortex-M3, either you can write it in the form of assembly level language or in the form of high level language. Assembly level language is nothing but we can write it move a comma m, LDR, LXI, STR, this kind of instructions. But in C language, as usually, if you are going to write it in the form of C statements, C language statement. In addition to that, one more language is support to this Cortex-M3 processor that is called as LabVIEW. It is developed from National Instruments. This LabVIEW also it is available. So to run this, to once write it the program, we can run these programs. We can use for different linker, compilers, loaders, everything we are going to use for this. This is nothing but, so we need assemblers, a C compiler, a linker, and a binary file generation utilization for developing Cortex N3 applications. Okay. Generally, the user ARM Cortex M3 applications program can be developed and built with the many steps. What are those steps? So I'm going to discuss these important steps. Now all of you please look into this slide. So here we have three types of uh, files are available. So okay, I will explain. So usually in the development flow, first you have to write it or write the program either in the assembly level language or in the C language. First you have to load .asm file name. If it is assembly level language .asm, if it is C language 1.c. Means that the primary name it may be retained same, but secondary name if it is assembly level language .asm, if it is C language .c. So once compile this program, the .asm files convert into .object files, .1.obj object files. In C language also same thing, .c files converted into the .object files. So once compile the either in the assembly level programming or in the C programming, convert into the object files. The primary file, the primary file is nothing but 1.asm. Convert into the object files, it become 1.obj. So once compile this program, if any syntax error in the programming, it will detect during the compiling time. Once compile the program, then finally execute the program or run the program. If run the program, .object file converted into .exe files. And similarly in the C programming also same thing. .object file converted into .exe files. So finally, exe files is a machine understandable language. .asm or .c files is a user understandable language. But .object files, it is in between that user and machine level languages. It's not understandable machine also it's not understandable even user also. But when we are going to use compiler to compile the program, one file is created that is called as object files. The object wise the file is created. Usually in any programming, in the form of assembly level language or in the high level language. If any program or any file, so instead of one file created, after once complete, it is created 3 files. Suppose for example, in the folders you created one folder, you have to create it with your USA numbers. Okay, one folder is created in your USA numbers. Within that folder, you have to save the file, the primary file .1 ASM file. If it is in the assembly level language, you return, they are stored in .asm files. So once compile and run, you look into that folder, 3 files are created. But .1.asm file only user readable programming. These two is a user, not usable, user readable programs. It is only the compiler and machine understandable languages. But 3 files are created. Okay, I hope that you are observed, already executed many programs, even in the C also, C language, as well as the assembly level language during the previous semesters. One controller, what you studied, 8051 controllers, during the time I think you are aware of this. But here I want to explain that the process or typical development flow, the procedure I am going to explain. In similar manner, even in the C program also same thing. The secondary name is .c. It is user readable program. Then .object file is a compiler understandable language. .exe file is a machine understandable language. Each folders, if you are stored only one file, but primary name it will be written same, but the secondary name, primary name is nothing but here is 1. Secondary name is C. Secondary name is .object. Secondary name is .exe files. Okay. In the similar way, here we in the process, in this process we are using C files. C files .c file means that you return the program in the C language by using printf, scanf, and all these things. Whatever the C language conditional instructions, unconditional steps, everything we are implemented to complete the program and save, store the file name with extension name .c. Okay. Now we use the compiler. The compiler name, it is called as harmcc. If you return the C language in the form in the microcontrollers, we are using the compiler harmcc. This is what one assembler, sorry, compiler we are using it. Once compile it, see here, please look into this. Object file is created. .o object files. .c is a primary first file, user readable. .object file is a compiler readable language. So once object file is created, then you can run the program. That is called as a linker. Run the program means link the program. That is what we have to use ARM link. See here, ARMCC for compiler, ARMLINK link. This is called linker. This is what compiler. If you compile this or execute this file, or it may be the image, it will be converted into the form of binary. It is .exe files, but it is machine readable languages. It is called as .exe files. If it is in the, so this is what in the general flow for that. Now here we use scattered loading scripts, memory layout we are using to utilize that. So linker, it support for these linkers, and linker to here, form, if, okay, form, if either it will go for disassembler. Assembler binary programming image is a disassembler, assembler code .txt files. So here, please look into this. This is what usual procedures. Similarly, I will come to that here assembly files. So here it will be written .s, actually is a .asm files. So in depends on some of the tools. For example, in this tool with the reference of CL written real view development shoot RVDC or real view compiler tool. If you are using these two tools, may assembly level language may save as .asm. Okay, so here this is the .asm file. Convert into the .object files. Here, please look into this object file. Once compile it by using ARM-ASM, and then it will goes to the linker by using ARM link, and then convert that object files into the binary files or in the exe files. This file, it is machine readable language, computer machine understandable only binary language. It is ones and zeros only. And this is what compiler. Compiler readable language, it is called as .object files. Then user designer readable file, it is called as either .c or in the .asm. If it is assembly level language, .asm. If it is in the C language, .c files. But the tool may use different. For example, Keel compiler also one type of tool is available. We can write the program in the form of C with 8051 microcontrollers operations. We can write it in the program. Our logic should be solved by using C language using Keel compilers. And some of the assembler tools are always available. Example 8086 assemblers or microcontrollers to write a program by using TASM tools we are using. Okay, TASM also one tool. It support for to enter the assembly level language. And one more tool is there, MASM, TASM and MASM. But they are old. These two tools are last few decades back they used in the assembly level language written to writing the codes. But now usually the majority of the applications we are going to write it in the form of C language only. Okay, so now I'll come to that. If you are using the C language, so what is the advantages of using C compiler? If you are using the C compiler, it is much easier and less time consuming to write program in C than assembly level language. So clearly, I'll explain once again how C language is better or advantages. C language is easier and less time consuming to write program in C than assembly language. Okay, and then we'll come to the next advantage by using C language. C language is more flexible and it is easier to modify and updates. It is flexible and it is easier to modify and updates. We can update easily, we can update. And this C program allows use to code available in function libraries. In C program, use codes available in function libraries. Some of the standard libraries are available in C language. We can use that libraries directly when we are going to use the C program, or C allows to use that libraries easily. That is one more advantage. And in C program, in C, for one microcontroller is portable to the other microcontroller with little and no modifications. Sometimes if you write it in the C language, we can portable from one microcontroller to the other microcontroller also. That option also is available by using C language. But if you use assembly level language, they not support for that. Fine. One more, the last advantage by using C language, in compiler can generate very efficient code. Okay, in C, compiler can generate very efficient code. So this is what the advantages by using C language compared to assembly level language. So this is what the overall view of development flow, the procedures. Very simple procedures, development flow. If it is in the C program, file name .c, for example, 1.c, you can take your USA number or your name .c. It's a primary name. Once compile, it convert into the object file. That is only compiler readable language .obj files. Once you can execute the program or you can run the program, generally it is called as a linker in terms of assembly level language. .object file converted into the .binary files or .exe files. Generally in your system, you can look into your system, it is called, it will be displayed .exe files. The primary name maintain the same thing, but secondary name change from .c to .obj, .obj to .exe file. This is what the development flow from source file to the machine understandable level. In some applications, maybe small project or small applications, whatever it may be. But majority of them still, even in the small applications, they are going to use or to develop the small project by using assembly level language only. But somebody they are very familiar, they are very confident with this assembly level language, they are going to use it. But if using the assembler, best optimization is possible, but it increases the development time. But in C, development time will be very less. But best optimization is available in assembly level language, but increase the development time. And here, handling complex data structures or function library management can be extremely difficult. Suppose if you are using assembly level language, the data structure or the functions we have to use to manage this is extremely difficult. But C, no issues for this problem. Can easily to manage that data structures and some of the functions and easily interact with the libraries. They are very easily to accessible in the libraries also. Okay, these are the advantages and disadvantages over C language and assembler language. Sometimes in the examination, compare the assembly level language and C language, you should write like this. Everything I will cover it. Either if you want, you can put it, make it 2 columns. You can write it properly. At least 4 to 5 differences you should identify it. Then only become very clear. The concept will become very clear. So now, after that, we'll come to that how we are going to interface between assembly language and C language. Of course, it is essential and it is required to interface between C and assembly language. But in various situations, assembly code and C as a program interact. When embedded assembly is used in C program code, when C program code calls a functions or subroutines, implemented in the assembler in separate files. Even sometimes in the assembler program calls the C functions or a subroutines. Mean that sometimes you can use both. If you written the program in assembly level language, we can call the subroutine from C. If you written the C program, we can implement the assembler in the separate file. We can interact. We can going to interact between these two. That is what the interface between assembly level language and high level language. Okay, then I'll come to that. So one more important concept, that is called as CMSS. So today's my session, I'll cover only two topics. First topic related to that, languages. Now secondly, I'll come to that. So CMSIS, Cortex microcontroller software interface standard. So what is the benefits of this Cortex microcontroller software interface standard? So here the generally we will call as short form in our presentation. I can call now onwards CMSIS. Reduce the learning curve, development cost, and time to market. It develops can write software quicker through a variety of easy to use standardized software interface. And it consists of software interface, improve the software portability and reusability. So software portability and reusabilities. And these software libraries and interface provide consistent software framework. It is available in this Cortex microcontroller software interface standard. And it provides interface for debug connectivity, because debug unit is inbuilt in Cortex-M3 process. It supports debug connectivity, debug peripherals view, how it will be debugging the some of the peripherals, and software delivery and device support to reduce time to market for new microcontrollers deployment. This is what the benefits by using Cortex microcontroller software interface standard. And in addition to that, it provides compiler independent layers that allows using a different compilers, and it's supported by mainstream compilers. It's supported by mainstream compilers. And it enhances the program debugging with peripherals interface or peripheral information for debuggers and channel for print style output for real-time operating system kernel awareness. Kernel means kernel is a main part of the operating system. In any RTOS, kernel is a major role. In this Cortex software interface standard, support for these real-time systems. Of course, already I told many times, these Cortex supported for real-time operating systems. Of course, if you are using in the real-time operating system, we can use or we can implement all these concepts through these CMSIS. Okay. So these are the benefits by using these Cortex microcontroller software interface. In the block representation, so here we taken the block representation. We have mainly three blocks. One is software block, input block. Second one, it is the device driver library. Of course, we called as a drivers library. And the last one, it is a microcontroller hardware. See, in the software, we look into these here, application software, embedded operating system, and middleware. And one more is there in the operating system, it's called as a firmware. So here we can use the middleware. All these interact through the driver. Through the driver means we have the driver libraries are available. Through the device driver libraries, we can go for controller hardware. The controller may be in the form of, see, maybe in the form of Cortex-M3 or Cortex-M0 or it may be Cortex-M1. Now the latest may be Cortex-M7 also like this. So this is what the overall flow for this software to the microcontroller hardware, how it will be going to interface for this. And if you are using these Cortex microcontroller software interface, what are the advantages also or benefits also I explain it. Okay, these are the very important parameters to be considered in case of Cortex microcontroller software interface. Okay, so now this is what that's today's my class overview. Okay.